Good morning children. How are you all? Hope you all are fine. Okay. Have you completed the previous homeworks and assignment given in redox reaction, oxidation number? Okay. I think you have completed. Okay. If you have any doubt, go through the book. Okay. Go through the book and see the examples, the formulas. Okay. Then you can do the problems. Okay. Right. Today we are going into second unit, unit 2, that is quantum mechanical model of an atom. Quantum mechanical model of atom. Okay. What is quantum mechanical model? Quantum means mathematics. Quantum means expression in numerical form. So, in this lesson we are doing the model of the atom, okay, mathematical in the model of atoms. So, the mechanical model of atom is expressed in terms of numbers, numerical forms in this lesson, okay. Okay children, let us go into this lesson. Okay, right. Erwin Schrdinger was a scientist, okay. He was a scientist. He was awarded Nobel Prize in Physics, okay. Schrdinger, okay. His name is Schrdinger. He was awarded Nobel Prize in 1933 for the discovery of new productive forms of atomic theory. So, Schrdinger had wide interests starting from chemistry, physics, maths and botany, okay. He has great subject in the field of science and maths, okay. He was not satisfied with the quantum condition. He was not satisfied with the quantum condition in Bohr's orbit theory and believed that atomic spectra should be determined by some kind of eigenvalue problems, okay, and he proposed a new equation, that is the wave equation. So, that wave equation is named after him, Schrodinger wave equation. So, in this lesson we are going to see about the wave equations also, okay. After completion of this unit, you may have some ideas about the atomic models, dual behavior of matter, okay, matter's behaviors, okay. You can understand the de Broglie equation, you can solve the numerical problems, okay, and Heisenberg's uncertainty principle, okay, and significance of quantum numbers, okay, shapes of various atomic orbitals, Aufbau principle, Hund's rule, Pauli exclusion principle. These are the main topics in this lesson, okay. Now, let us recall the history of development of atomic models, okay, in the previous classes, okay. In your small classes itself, you have studied about atoms, okay. We all know that everything are made up of matter, everything are made up of matter, okay. The basic unit that makes up the matter is called atom. The basic unit that makes up the matter is called atom, okay. The word atom has been derived from the Greek word atomino, okay. That meaning is non-divisible, So, atom was considered as a non-divisible in the previous, but after the discovery of subatomic particles such as electron, proton and neutron, okay, after the discovery of electron, proton, neutron, it is not said as non-divisible, okay. So, J.J. Thomson, okay, J.J. Thomson's cathode ray experiment, okay, that is an experiment which reveals the atom consists of negatively particles called electrons. Electrons on the atoms la irukku அப்படிங்கறத J.J. Thomson ஓட cathode ray experiment மூலமா தான் discover பண்ணாங்க, okay. அவர் என்ன propose பண்ணார்னா, atom is a positively charged sphere in which electrons are embedded like seeds in the watermelon. Have you seen watermelon? Yeah, in that watermelon, how the seeds are embedded, that seeds are electrons in atoms, okay. Watermelon la இருக்கக்கூடிய seeds மாதிரி atoms la என்ன இருக்கு, electrons இருக்கு, okay. Okay, he proposed. Who proposed? J.J. Thomson, okay. Later, after J.J. Thomson said it, Rutherford, he discovered, he proved that J.J. Thomson's discovery was wrong, okay, by an experiment, that is alpha ray experiment, alpha ray scattering experiment, okay, that proved that Thomson's model was wrong. Further, Rutherford bombarded a thin gold foil with a stream of fast moving alpha particles, okay, fast moving alpha particles, okay. Okay, it was observed that, see the first point, most of the alpha particles passed through the foil. Okay, take your book, page number 39. Take your book, page number 39. There is a picture. Okay, that is the Rutherford's alpha scattering experiment. Okay, here what happens? See, the arrow marks like star particles. Okay, arrows with stars, that is the particles. Okay, alpha particles are passed through the foil. That white sheet, no, sandal color sheet. Okay, that foil, alpha particles are passed through. Some of them are deflected, some of them are deflected, some of them are reflected. Some of them are deflected and some of them are reflected back. Okay, போன இடத்துக்கே திரும்ப வந்துருது, that is the reflection. So deflected means some of them are gone on the other side. Okay, some of them are came back. So who discovered this? Rutherford. Okay, based on these observations, he proposed that in atom there is a tiny positively charged nucleus. Okay, in a atom there is a tiny positively charged nucleus. Okay, and the electrons are moving around the nucleus with high speed. Okay, electrons are moving around the nucleus with high speed. So the theory of electromagnetic radiation, electromagnetic radiation states that moving charged particles should be continuously lose its energy in the form of radiation. Okay, in the form of radiation. So therefore the moving electron, ஒரு atomல இருக்கக்கூடிய moving electron should continuously lose its energy, finally collide with nucleus, which resulting in the collapse of atom. However, this does not happen and atoms are stable. So moreover, this model does not explain the distribution of electrons around the nucleus and their energies. It does not. Rutherford's experiment does not explain the distribution of electrons around the nucleus and their energies. Okay, that's all. Now what is Bohr model of atom? Bohr's atom model. Okay, the Planck and Einstein, the scientist Planck and Einstein showed that energy of electromagnetic radiation is quantized in units of hV. What is hV? H is a Planck's constant. Okay, that is 6.626 into 10 to the power minus 34. H அப்படிங்கிறது ஒரு Planck constant, V ங்கிறது ஒரு frequency. So hV. Okay, the radiation in terms of hV. Who discovered that? Planck and Einstein. Okay. Further extending the Planck's quantum hypothesis to the energies of atoms, Niels Bohr proposed a new atomic model for the hydrogen atom. Okay, new model. This model is based upon the following assumptions. Okay, what happened? First of all, the energies of atoms in an atom are quantized. Okay, the energies of atoms, energies of electrons, atomல இருக்கக்கூடிய electrons ஓட energies are quantized, means written in numbers. Okay, now the electron is revolving around the nucleus. Okay, electrons are revolving around the nucleus in a circular path of a fixed energy called stationary orbit. Okay, see the picture, that is the center one is the nucleus and சுத்தி circles are there, no, that are the orbits, orbit and orbitals. Okay, first shell, second shell. In the first shell only 2 electrons state. Okay, second shell only 8, third shell 18, fourth shell 32. Okay, a small nucleus of protons and neutrons are surrounded by electrons. Okay, சென்டர்ல ஒரு நியூக்ளியஸ் இருக்கும், சரியா? ஒரு ஆட்டம்ல சென்டர்ல ஒரு நியூக்ளியஸ் இருக்கும். நியூக்ளியஸுக்கு உள்ளார protons and neutrons are present. Okay, inside the nucleus protons and neutrons are present. Okay, further they are surrounded by electrons. Okay, surrounded by electrons. See the picture, சென்டர்ல இருக்கக்கூடியது தான் நியூக்ளியஸ். Okay, சுத்தி ரிவால்வ் ஆகிறது யாரு? எலக்ட்ரான்ஸ். Okay, and என்ன ஆகும் அப்படின்னா எலக்ட்ரான்ஸ் எப்படி ஃபில் ஆகும்? ஃபர்ஸ்ட் ஷெல்ல 2 தான் இருக்கும், அப்புறம் செகண்ட் ஷெல்ல 8, third shell 18, fourth shell 32. You should remember. Okay, first shell 2, second shell 8, third shell 18, fourth shell 32. Okay, each shell holding up to the maximum number of electrons and filled from the first shell to outwards. Okay, that are strongly held and therefore at the lowest energy level. So the theory couldn't explain certain detailed aspects of the chemistry of the element. Okay, this Bohr's atomic theory does not explain the detailed aspects of chemistry about or their emission spectra. Okay. Further, he also discovered that electron can revolve only in the orbits. Electron can revolve only in the orbit because there is an angular momentum. We have studied in physics angular momentum, that rotation. Okay. That rotation is mvr. Okay. mvr equal to nh by 2 pi, that is equal to the integral multiple of h by 2 pi. H is the Planck's constant and 2 by pi, where n equal to the integers. Okay. So, as long as the electron revolves in the stationary orbit, it does not lose energy. Okay. Evlo sutnalum, it does not lose its energy. So, it does not lose energy. However, when an electron jumps from higher state to lower energy state. Okay. Electron is jumping from higher energy state to lower energy state. So, the excess energy is emitted. So, the emitted energy is radiation, that is the radiation, that is written as E2 minus E1. What is E2? Highest minus E2 lower. So, higher energy minus lower energy is equal to HV. H is the Planck's constant, V is the frequency. So, from that we can derive formulas. Okay. So, applying the Bohr's postulates to hydrogen atom, one electron species such as H, He plus, Li2 plus, okay, the radius of nth orbit and energy of the electron revolving in the nth orbit were derived. So, the derivations are up to minute levels. Okay. Up to minute levels also we can find. So, this Bohr atom determine the suitable energy that is supplied to the electron, which will jump from lower to higher, higher to lower. So, that energy liberated is called the radiation. Okay. Now, there are not only advantages, there are also negativities in that Bohr's atom model. So, that is called the limitation. Okay. What are the limitations? Let me tell. The Bohr's atom model is applicable only to the species having one electron. Okay. In the Bohr model concept, one electron irukkudiya species such as hydrogen, lithium, etc. Okay. And அதோட வேலன்ஸ்ல ஒரு எலக்ட்ரான் தான் இருக்கும். ஓகேவா. So, it is not applicable to multi electrons, not applicable to multi electrons, applicable only for one electron. Okay. So, it was unable to explain the splitting of spectral lines in the presence of magnetic field or electric field. So, both the Bohr's theory was unable to explain why the electron is restricted to revolve around the nucleus in a fixed orbit in which the angular momentum of the electron is equal to nh by 2 pi, okay, which was provided by Louis de Broglie. Okay, you will study these things in your higher standards. Okay, now here only the basic one is given. Okay, okay, you should study the Bohr atom model and limitations of Bohr atom model is important question. Okay, in Bohr's atom model, quantum idea of stationary orbits is mixed with the classical idea of Coulomb force. Okay, the assumption of only circular orbit is utterly unjustified. Okay, it can only explain the line of hydrogen and hydrogen atom. I said you that Bohr's atom model will only explain about one electron. In the elements like hydrogen, okay, lithium, okay. What are the elements? Sodium, potassium, hydrogen. This எல்லாமே ஒவ்வொரு metals, non-metals, these are the elements. Okay. எந்தெந்த elementsல ஒரு electron தான் அந்த final valence shellல இருக்குதோ. What is the valence shell? Valence shell அப்படினா last shell. Okay. Centerல nucleus சுத்தி ஒரு orbit, next ஒரு orbit, next ஒரு orbit. அந்த electronோட path தான் என்னது orbit. Okay. So, last orbit இப்போ hydrogen எடுத்துக்கிட்டீங்கன்னா ஒன்று தான் ஒரு electron. So, அதுதான் last one. Okay. So, அந்த ஒரு electron தான் அந்த ஷெல்லில் வருது அப்படின்னா, இப்போ லித்தியம் இருக்குன்னா அதுக்கு லாஸ்ட் ஷெல்லில் ஒன்று மிச்சம் வருது அப்படின்னா, ஸோ எந்த வேலன்ஸ் ஷெல்ஸ்லாம் last only one electron is there, only Bohr's model நம்ம apply பண்ணி அதன details கண்டுபிடிக்க முடியும். So, it cannot explain the fine structure of hydrogen atom and it cannot make any calculation about the transition or selection rules. Okay. So, these are some limitations of Bohr's model. Okay. Now, what is wave particle duality? What is wave particle duality? Okay. Okay, Albert Einstein proposed that light has a dual nature. Light has dual nature, that is light photons behave like both particle ஆவும் behave பண்ணுது, wave ஆவும் behave பண்ணுது. That is the duality. That is the duality. Light க்கு two nature இருக்கு, dual nature. Light has dual nature, wave nature இருக்கு, particle nature இருக்கு. அப்படிங்கறத யார் கண்டுபிடிச்சா? Albert Einstein. Okay. So Louis de Broglie extended this concept that all the forms of matter showed dual character. Okay. Louis de Broglie said that all forms of matter has dual character. So to quantify this relation, he derived an equation for the wavelength of the matter wave. So he combined the two equations of energy, which represents wave character and other represents particle nature. Okay. Wave character and particle nature. Okay. So Louis de Broglie proposed that all matter have wave and particle properties. Okay. Albert Einstein வந்து first கண்டுபிடிச்சு சொல்லிட்டாரு. என்ன சொன்னார்னா லைட்டுக்கு வந்து dual nature இருக்குன்னு சொன்னாரு. அவர் சொல்லிட்டு போயிட்டாரு. அதுக்கப்புறம் லூயிஸ் டி ப்ராக்லி என்ன பண்ணாரு, அந்த கான்செப்டை எடுத்துக்கிட்டாரு. லைட்டுக்கு ரெண்டு நேச்சர் இருக்குங்கிறத நம்ம மேத்தமெட்டிக்கலாக ப்ரூஃப் பண்ணணும். இந்த லெசனே என்ன அப்படின்னா இருக்கக்கூடிய கான்செப்டை மேத்தமெட்டிக்கலாக ப்ரூஃப் பண்ணுறது. தட் இஸ் த குவாண்டம் மெக்கானிக்கல் மாடல். ஸோ ஃபர்தராக யார்? டி ப்ராக்லி extended this concept. Okay. He proposed all forms of matter and showed the dual character. He said that every matter, not only light, all the matter have wave and particle properties. Okay. Not just electrons. Like that de Broglie proposed. Okay. So E equal to hv. E equal to hv, that is a Planck's quantum hypothesis, that is a Planck's theory. First equation E equal to hv. Okay. Further, Einstein's mass energy equation is what? E equal to mc square. So E equal to mc square and Planck's constant when the E is equal to hv, that is written as h c by lambda. H c by lambda, where V equal to c by lambda. Okay. Now h c by lambda equal to mc square. Okay. Write down the equation h c by lambda equal to mc square. Further, h is equal to mc square by lambda. Now h is equal to mc lambda because c cancels each other. So lambda equal to h by mc. Okay. Further, lambda equal to h by mv because the c is written as v. Photons have zero rest mass. Okay. So the velocity, moving velocity c is written as v. So lambda equal to h by v. Further, the final value lambda equal to h by mv. This is the valid when particle travels at speed much less than the speed of light. So every particle travels at a speed which is less than the speed of the light. Okay. For example, lambda of baseball. Okay. That is mass வந்து 2 kilogram and velocity equal to 30 meter per second. So you have to find h வந்து Planck's constant. Lambda கண்டுபிடிக்கணும். Lambda equal to h by mv. h வந்து Planck's constant 6.62. Like that, it is a constant value, isn't it? 6.626 into 10 to the power minus 34 divided by mass 2 kg into velocity 30. So you have to find the answer. Okay. And further, lambda of electron கண்டுபிடிங்கன்னு சொன்னாங்கன்னா mass value கொடுத்திருக்காங்க, velocity value கொடுத்திருக்காங்க, h வந்து constant நமக்கு தெரியும். So lambda equal to, lambda is the wavelength. So wavelength equal to h by mv என்னன்னு நீங்க என்ன செய்யணும்? கண்டுபிடிக்கணும். Okay. For solving the problems, okay, for solving the problems you have to know the wave particle duality. Okay. Wave particle duality is also important question. Write it as a derivation. Okay. Now quantization of angular momentum and de Broglie concept. Okay. Angular momentum and de Broglie concept வச்சு quantization பண்றாங்க. According to this de Broglie concept, electrons revolves around the nucleus, exhibits both particle and wave character. Okay. De Broglie என்ன சொன்னாரு? Electrons வந்து it is having particle and wave character. So in order for the electron wave to exist in a phase, the circumference of the orbit should be an integral multiple of the electron wave. So circumference of the orbit is n lambda. Circumference of the orbit is n lambda. So rearranging it. Okay. 2 pi r equal to n lambda. Circumference of the circle 2 pi r equal to n lambda. So 2 pi r equal to lambda is written as h by mv. Okay. H by mv. So rearranging it, mvr equal to nh by 2r. Further we will get the angular momentum. Okay. These are the wave nature of electrons in Bohr orbit. See the picture. These are the wave nature of electrons in Bohr orbits. Okay. First one not allowed. Okay. Second one that is allowed. Third one the number n equal to 3 and further n equal to 4. So see there n equal to 3 means 3 sides irka looking like a triangle. and n equal to 4 means 4 sides are there. 1, 2, 3, 4, that is a wave nature, and n equal to 5, that is also in a wave nature, 5 star like 1, 2, 3, 4, 5. n equal to 6 means 6 sides in a wave form. These are the wave nature of electrons. So, wave nature means it is rotating, it is moving in a wave motion. If n according to the value, okay. Now, Davison and Germer experiment, okay. The wave nature of electron was experimentally confirmed by Davison and Germer, okay. Wave nature was experimentally யார் கன்ஃபார்ம் பண்றா? Davison and Germer தான் இந்த வேவ் நேச்சர், எலக்ட்ரான்ஸ்க்கு வந்து வேவ் நேச்சர் இருக்கு, எலக்ட்ரான்ஸ் வந்து வேவ் மூவ்மெண்ட்ல தான் மூவ் ஆகுதுங்கிறத கண்டுபிடிச்சு எக்ஸ்பெரிமெண்ட்டாக கண்டுபிடிச்சவர் யாரு? Davison and Germer. So what they are doing, they allowed the accelerated beam of electrons. See the picture, they are giving the accelerated beam of electrons to fall on a nickel crystal, and recorded the diffraction pattern, and they are recording the diffraction pattern, okay. What happened? The diffraction pattern is similar to the X-ray diffraction pattern, okay. Diffraction pattern is similar to the X-ray diffraction pattern. So the finding of wave nature of electrons leads to the development of various experimental techniques such as electron microscope, low energy electron microscope, okay. These are the various structures, okay. In the previous picture I have given though, that is the wave formats, okay. So in this experiment, electrons of known momentum are beamed onto the crystal, okay. Now the electron waves diffract from the crystal lattice just as the X-rays of the same wavelength, okay. It gives a diffraction pattern which is measured by the rotating electron detector and plotting intensity versus angle. Here கீழ ஒரு graph போட்டிருக்காங்க, okay. That is intensity versus angle எவ்வளோ intensity pass ஆயிருக்கு, like that, okay. This is the Davison and Germer experiment. They have confirmed that wave nature of electron is true, and that is very correct, like that. They have discovered the de Broglie concept experimentally, that is derived by the Davison and Germer, okay. See the picture, there is a sharp peak, okay, from the constructive interference between the electron waves and scattered from the different atoms on a surface, that is the peak surface, okay. In that place, okay, the atoms, the waves were scattered, okay. The heating filament emits electron, heated filament emits electron, the electrons are accelerated by electrons and directed at the crystal, okay. Further, electron beam is going through the vacuum, it is given by a voltage, voltage is given, then only electrons are accelerated. Further, there is a detector that is moved to detect the scattered electron at any angle. Electrons are striking the nickel crystal, okay. Now Heisenberg uncertainty principle. What is Heisenberg uncertainty principle? The uncertainty principle states that the position and momentum cannot both be measured exactly at the same time, okay. The dual nature of matter is having dual nature, it imposes the limitation on the simultaneous determination of position and momentum of a microscopic particle. So based on this Heisenberg came to an uncertainty principle that it is impossible, okay. The Heisenberg uncertainty principle is an important question. In each and every question paper, this question is there, okay. Very important, note it down, okay. Important 2 mark, okay. Sometimes it is asked in 5 mark, maximum it is asked in a 2 mark question, very important, mark it, okay. So it is impossible to accurately determine both the position and momentum of a microscopic particle at a time, okay. This is the main word, impossible to accurately determine the position and momentum of a microscopic particle. So the product of uncertainty, that is the error. So the product of uncertainty in the measurement is expressed as del x dot del p, that is greater than or equal to h, del x dot del p that is greater than or equal to H. Okay. So where del x and del p are uncertainties in determining the position and momentum. Where del x and del p are uncertainties in determining the position and momentum respectively. Del x is the change in what? Position, distance, okay, del x. Del p the momentum, change in momentum. So change in length, change in momentum. So multiply it, that is greater than or equal to h by 4 pi. H by 4 pi. So the uncertainty principle has a negligible effect for macroscopic objects. So macroscopic object irundana in the principle work agadu. Becomes significant only for microscopic particles. Only this principle is working for microscopic particles such as electrons. Okay. You understood? The more accurately you know the position, the less accurately you know the momentum. That is the main concept. Okay. Delta x, delta b greater than or equal to h means the more accurately you know the position, the less accurately you know the momentum. Okay. Where h is the 6.624 into 10 to the power minus 34. That is the Planck's constant. If h is so small, the uncertainties are not observed in the normal situation. Okay. Therefore, the uncertainty in the velocity of the electron. Or electron la vandu velocity ku or uncertainty level irukna, it is comparable with the velocity of light. So at the high level of uncertainty, it is very difficult to find the exact velocity. Now, Schrdinger equation. I already told that Erwin Schrdinger was a scientist. Okay, he had discovered many productive forms of atomic theory, great interests in science such as physics, chemistry, biology, etc. But finally, he proposed the wave equation. Okay, wave equation, which is a very good and perfect equation by Schrdinger. So the wave equation is given by his name itself, that is Schrdinger equation. Okay, what this equation says, let me tell you. The motion of objects, okay, objects irukku, adu movement aganum, motion of object that we come across in our daily life. In our daily life, the motion of objects that we come across, we will describe using classical mechanics. In physics, I have told that classical mechanics, modern mechanics. Okay, so in the previous, okay, that is based upon Newton's law of motion. So Newton's law of motion. So in classical mechanics, the physical state of the particle. In classical mechanics, what happens? The physical state of the particle is defined by its position and momentum. Okay, defined by its position and momentum. So if we know both these properties, we can predict the future state of the system based on the force acting on it using the classical mechanics. If you know both these properties, we can predict the future state of the system. Okay, if you know the position and momentum, main word is position, momentum. If you know these properties, we can predict the future state of the system, that is based on the force acting on it. That is using by the classical mechanics. So, however, according to Heisenberg's uncertainty principle, both the properties cannot be measured simultaneously. Okay, according to Heisenberg's uncertainty principle, apply panni pathona, both the properties, that position and momentum, cannot be measured accurately for microscopic particles such as electron also. Okay, so the classical mechanics does not consider the dual nature of matter, which is significant for microscopic particles. So as a consequence, it fails to explain the motion of microscopic particles. So based on the Heisenberg's principle and dual nature of microscopic particles, a new mechanics called quantum mechanics was developed. Okay, quantum mechanics. Okay, that is the Schrdinger wave equation. He expressed that wave equation in terms of differential equation. Have you studied differential equation? Yes, differential equation means change of a quantity, rate of change. Okay, rate of change, higher minus lower, the difference. Okay, the difference between the elements, that is expressed in terms of differential equation. So Schrdinger expressed the wave nature of electrons in terms of differential equation. Okay, this equation determines the change of wave equation in space. This equation determines the change of wave equation in space depending on the field of force in which the electron moves. Okay, the time independent Schrodinger equation can be expressed as H psi. Okay, that psi equal to E psi. H is the Hamiltonian operator. See the equation H cap is there, no? That H is called Hamiltonian operator. Hamiltonian operator. Okay, this is a big equation. Okay, I will explain you in the next classes. Okay, right. See here, H equal to minus H square by 8 pi square m. Okay, dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Okay, these are differential forms you will study in your maths. Okay, plus v, you remember this equation. Okay, this equation, that first equation H is equal to written, no, that is a differential equation. That equation is written as C minus H square by 8 pi square m, the same constant value, and extra psi values added, dou square psi by dou x square plus dou square psi by dou y square, that is the psi. Okay, that symbol, no, that is called psi, plus dou square psi by dou z square plus v psi equal to E psi. Okay, so H equal to what? H equal to E. So H psi equal to E psi. So we are writing this equal to E psi. Now we are multiplying by minus 8 pi square m by H square, and we are rearranging the equation. Further we will get dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square by 8 pi square m by H square, open the bracket, E minus v into psi, that is equal to 0. Okay, have you understood, children? The above Schrodinger wave equation does not contain time variable. See the equation, is there any time variable? So it is independent on time. So wave equation is independent on time. Okay, this equation can be solved only for certain values of E. That capital E is the total energy. What is the total energy? The energy of the system quantized. Okay, energy of the system quantized, that is called the total energy. Now the permitted total energy values are called eigenvalues. The permitted total energy values are called eigenvalues, and corresponding wave functions represents the atomic orbitals. Atomic orbitals. Okay, these are the Schrodinger equation. Okay, children, have you understood? Have you understood what is the model, what is the atomic model, and what is the Bohr atomic model, and the limitations of Bohr atomic model, and the wave particle duality of matter, and the quantization of angular momentum and de Broglie concept, and Davison and Germer experiment, Heisenberg uncertainty principle, okay, and Schrodinger equation. Okay, children, these are today completed. Okay. Now it's time for your homework. Okay, you have to write 10 one words from page number 38 to 43. Okay, this topic is very important one. Okay, you should go through it. Okay, study well. Okay, very important questions are Bohr atomic model, Bohr atomic model, and limitations of Bohr atomic model. Okay, you have to write it. Okay, write it in your classwork. Okay, Bohr atomic model, write it in your classwork. Heisenberg uncertainty principle, write it as a assignment. Okay, write it as a assignment. 10 one words write in your homework note. And Bohr atomic model, you write it in your classwork note. Heisenberg uncertainty principle, you write it as a assignment. Okay, children, that's all. Study well. Okay, don't waste your time. Okay, be safe. Okay, stay home, stay safe. Thank you.